This problem is for you to try yourself. We're asked here to use the definition of the derivative to find f prime of x if f of x is equal to the function 3 divided by 4x plus 2, where x is not equal to minus 1/2. And the reason we exclude this value from the domain of the function is that you can see that when x is equal to minus 1/2, the denominator will be 0. So let's recall the definition of the derivative that you'll be using. This is the limit as h goes to 0 of f of x plus h minus f of x over h. And we're going to pause the video so you can go ahead and try to apply this definition to the function given. Continuing, we're going to plug in x plus h for x in the function, and here we just have the given function f of x. Let's see what that looks like. So we have the limit as h goes to 0. Now f of x plus h, whenever we have a function, the x is a placeholder, and we drop into that placeholder whatever appears in the parentheses. So it looks like we're going to get 3 divided by 4 times the entire quantity x plus h plus 2 minus, and f of x is simply 3 divided by 4x plus 2, and that's all over h. And now it looks like we've got to do a little algebra. So I'll pause again and let you go ahead and try and subtract these two fractions, and we'll resume the video if you get stuck. Let's proceed and try and add these two fractions in the numerator together. So we have 3 divided by 4 times the quantity x plus h plus 2 minus 3 divided by 4x plus 2. And that's just the numerator. We're just looking at the numerator. Now, how do we go about finding a common denominator? Well, the easiest way to find a common denominator is to simply take the product of the two denominators. So let's do that. We get 4 times the quantity x plus h plus 2 times 4x plus 2. And that's going to be both denominators, so let's try and rewrite this as two expressions, each with the same denominator. Now, how do you find a fraction that's equivalent to this one with this denominator? Well, it seems to be the case that we have multiplied the denominator by 4x plus 2, so to have an equivalent expression, we have to multiply the numerator times 4x plus 2. And in fact, you can see that if you canceled the 4x plus 2 in each case, you'd get the original fraction. So what about the other one? Well, here we have denominator of 4x plus 2, and it appears we're multiplying it by this more complicated denominator. So let's go ahead and multiply the numerator 3 by that more complicated denominator and check that indeed, if we canceled this factor here and here, we'd have this expression. So now I'm going to pause the video again, let you do a little of the algebra involved, and we'll carry on when we resume the video. So continuing, we're going to put everything over this common denominator and combine these fractions. So there's the denominator. What happens in the numerator? Well, here we have 12x plus 6. That's 12x plus 6, and here's a minus 3 times, let's see what we have here. We've got 4x plus 4h plus 2. Continuing, we're going to use the distributive law in the numerator, and we get minus 12x minus 12h and minus 3 times plus 2 minus 6 over our denominator, 4x plus 2. So we can do some canceling here. The 12x's cancel, the 6's cancel, and we're left with minus 12h over our common denominator. So we'll stop again, give you a chance to put this into the numerator of the definition of the derivative and see what you get. Now let's return to the definition of the derivative, and remember that we get the expression f of x plus h minus f of x in the numerator, and that we've found to be minus 12h divided by 4 times the quantity x plus h plus 2 times 4x plus 2, and that's all divided by h. Now you remember that here we have a fraction, and we're dividing that fraction by h. Well, that is the same as multiplying by 1 over h. So let's take our numerator, x plus h plus 2 times 4x plus 2, and instead of dividing by h, we'll multiply by 1 over h. So something nice happens here. The h's cancel, and now we have one more step to go ahead and take the limit as h goes to 0. Stop and let you do that, and finish off in 1 second. Okay, well, what is the limit as h goes to 0? There are no h's left in the problem except for that lone h in the denominator, and that's going to go to 0. So we are left with minus 12 divided by, this h is gone, so we have 4x plus 2 times 4x plus 2. We get 4x plus 2 quantity squared, or if you like, minus 12 times 4x plus 2 to the minus 2. And if you did the derivative using rules for differentiation, you might have seen very quickly that this is the answer. We found it by actually using the definition of the derivative, and that concludes this problem.